Okay, so in this lesson we're going to add and subtract rational expressions, and these are going to be with unlike denominators. In the previous lesson you added and subtracted rational expressions with like denominators, so these would be unlike. So in this lesson we're also going to talk about writing equivalent fractions. So this is going to be part one. So I'm going to divide the problems into two parts. Now before we move on, let's review something from a previous course. So let's suppose we wanted to subtract these two fractions. Now recall that, or notice that these two denominators are different. So these two fractions do not have the same denominator. They don't have the same partitions. So remember, in order to add or subtract fractions, you have to have the same denominator. So you have to find the least common denominator of these two denominators. So the LCD of these two fractions, so the least common multiple of 16 and 6 is 48. Okay, so you're going to write two fractions with that denominator. So this would be called writing equivalent fractions. Equivalent fractions. All right. So what you did was you're gonna determine 3/16 is equivalent to what fraction divided by 48, and then 5/6 is equivalent to what fraction divided by, or what numerator divided by 48. Okay, so you want to rewrite 5/6 with a fraction equivalent to a fraction with its denominator. You want to write 3/16 with to a fraction that's equivalent to this denominator. So what you did was you said 16 times what is 48, so you said 3. And what you did to the denominator, you did to the numerator. So 3 times 3 is 9. 6 times 8 is 48. So what I did to the denominator, I did to the numerator. So 5 times 8 is 40. And then now that the two fractions have the same denominator, you just subtract their numerators. So 9 subtract 40 is a negative 31, and then 48. So 9 48 subtract 40 over 48 is a negative 31 48. All right, so that's the idea we're going to use with rational expressions. Okay, so let's look at this example. So directions will say perform the indicated operations. All right, so perform the indicated operations. So remember the process we went through here. We're going to use the same idea here, except these will be dealing with variables as well. Okay, so number one, let's suppose we had 4 divided by 2x plus 9 divided by 3x. All right, so in previous lessons, you learned how to find the least common denominator of these two fractions. So the LCD of 2 and 3, start with the coefficients. The LCD of 2 and 3 is 6. And I have a factor of x. I only have one factor here. I have one factor here. So remember, you always take the one with the largest exponent. The larger number of 1 and 1 is 1. So the LCD is 6x. So once you find the LCD, then the next step is to write equivalent fractions. So you want to rewrite those two fractions with that denominator. So notice you're going to rewrite those two fractions with this denominator, just like you did here. So the LCD was 48. You rewrote those two fractions and you want this denominator. So you want this denominator. So you got to find the LCD first, the least common denominator. All right, and then you ask yourself, 2x times what is 6x? So what do I need to multiply 2x by to get this 6x? So I already have an x. I need to go from a 2 to a 3, a 2 to a 6. I need to multiply by 3. So if I multiply the denominator by 3, I have to multiply the numerator by 3. So 3 times 4 is 12. And always check yourself. If I divide the numerator and the denominator here by 3, 12 divided by 3 is 4. 6x divided by 3 is 2x. All right, over here, 3x times what will give me 6x? Now if you think about it, the answer is 2, because 3 times 2 is 6, and 3x times 2 is 6x. But what I do to the denominator, I do to the numerator. 9 times 2 is 18. All right, so once you write equivalent fractions, so I just wrote equivalent fractions. So 4 over 2x is the same as 12 over 6x. 9 over 3x is equivalent to 18 over 6x. So once you get the same denominator, you just add their numerators. 12 plus 18 is 30, so I get 30 divided by 6x. And then the directions will say simplify if possible. So right here it'll say simplify if possible. All right, so simplify if possible. So if you look at 30 divided by 6x, 30 and 6, they have 6 in common, so I can reduce. So 6 and a 6 is 1, 6 and a 30 is 5, so I get 5 divided by x. So that will be the answer. The answer is not 30 divided by 6x because you can simplify. So the answer is 5 divided by x. All right, so that was number 1. Number 2, let's suppose you had 3 divided by x plus 5 divided by 2x squared. All right, so 3 divided by x plus 5 divided by 2x squared. So over here, again, the denominators are different. The denominators are not alike. So you got to find the LCD of those two fractions. So the LCD will be, so right here, this coefficient is to be a 1. So the LCD of 1 and 2 is 2. And here you have one factor of x. Here you have two factors of x. You got to use the one with the largest exponents. I need 2 factors of x. So that's your LCD. All right, so the LCD is not 2x cubed. That is a common denominator. You want to use the least common denominator. So if you use the least common denominator, it makes things a little bit easier for you. All right, so you're going to write 2 fractions that are going to be equivalent to 3 over x and 5 over 2x squared. So 3 divided by x is equivalent to what numerator divided by 2x squared. And then 5 divided by 2x squared is equivalent to what numerator divided by 2x squared. All right? Okay, so let's look at this one. I have an x, I want to go to 2x squared. All right, so I have one factor of x, here I need 2 factors of x. And here I have a coefficient of 1, I want a 2. So what do I need to multiply? What do I need to multiply x by to get 2x squared? So if you said 2x, that's correct. And always check yourself. 2x times x is 2x squared. But what I do to the denominator, I have to do to the numerator. So 2x times 3 is 6x. So I get 6x here. All right, over here, that's a 2x squared. I want to end up with a 2x squared. Well, those are the same. So since the denominators are the same, it's kind of like saying times 1. So 2x squared times 1 is 2x squared. So since the denominators are the same, the numerators have to be the same because that's the same thing as saying times 1. 5 times 1 is 5. All right, and so therefore, since the denominators are the same, since those two fractions have the same denominator, I just add their numerators based on the previous lesson. So that's going to be 6x plus 5 divided by 2x squared. All right, now remember it says simplify, so what you want to try and do, notice this is a monomial, but this is a binomial, so what you want to try and do, just like in the previous lesson, you want to see if you can factor anything. So nothing here can be factored, so there's your answer. You cannot simplify. All right, let's look at this one. That's number 3. Let's suppose we had, let's see, number 3. Suppose we had 6 divided by x plus 1 plus 10 divided by 2x plus 2. So 6 divided by x plus 1 plus 10 divided by 2x plus 2. So the first thing you want to do, just like in previous lessons, is to factor your denominators. So whenever possible, factor your denominators. See, the thing here with the previous two problems, those were monomials. The denominators, look at your denominators, those are monomials. These are monomials. But here, we no longer are dealing with just monomials in my denominator. So this is a binomial, this is a binomial. So the first thing you want to do is see if you can factor your denominators. All right, so step 1, if you don't have any, if you have something other than a monomial, you want to see if you can factor the denominator. So here, I can factor out a 2, and I get 2 times x plus 1. All right, so it's kind of like replacing this as, if you need to rewrite it, go ahead and do so. It's kind of like replacing this second fraction as 10 divided by 2 times x plus 1. All right, now, There are several things you can do here. You can go directly from here and you can find the LCD. That's one approach. So one approach is to find the LCD. So the LCD of these two fractions. See, this factor is an x plus 1. You have to have an x plus 1 in your LCD. The question is, how many factors do I need? I have one factor here. I have one factor here. Remember the exponent. I have one factor here, so I need one factor. All right, so I know I'm going to have an x plus 1 in my LCD. The other factor I see is a 2. There are no other factors that are coefficients, so to speak, except this would be a 1. If you put this in parentheses, that would be a 1 here. So the LCD would be, you have to include this 2, so the LCD would be 2 times x plus 1. All right, now, if you, okay, now, so once you find the LCD, the next step is to rewrite equivalent fractions. So 2 times x plus 1 plus 2 times x plus 1. Okay? All right, so I want to go from x plus 1 to 2 times x plus 1. So I got to multiply this right here by 2. So I got to multiply this by 2. So that now looks like this. But what I do to the denominator, I have to do to the numerator. So 2 times 6 is 12. So that becomes a 12. All right, over here, this 2 times x plus 1 is already here. So it's kind of like saying times 1. 2 times x plus 1 times 1 is this LCD. But what I do to the denominator, I have to do to the numerator. So that's times 10 times 1 is 10. And so all I do now is since the denominators are the same, I add their numerators. So 12 plus 10 is 22. And then I get 2 divided by x plus 1. All right. Now remember the directions. The directions said to simplify if possible. So if you look at 22 and 2, I can reduce that. I can simplify that. 2 and 2, 2 is 1. 2 into 22 is 11. So I get 11 divided by x plus 1. Right, so there's your answer. So 11 divided by x plus 1. Now, I want to say this. I'm going to go back and I'm going to rewrite this part right here. So I'm going to put a little r here just to show you something. So I get 10 divided by 2 times x plus 1. All right. Now, you could have done what I'm about to do. So you see the second fraction. I'm going to cover up this part right here. So you see the second fraction where you had 10 divided by 2 times x plus 1. I can reduce the 10 halves. See, I'm covering this factor up. So I can reduce the 10 halves. So I can say 2 divided by 2 is 1. 2 divided into 10 is 5. And so you would end up with 6 divided by x plus 1 plus 5 divided by x plus 1. And notice the denominators are the same. So you just add their numerators. So 6 plus 5 is 11. So you get 11 over x plus 1. So you get the same answer regardless. All right, so just notice these things sometimes. Sometimes you can automatically reduce, and it may make things a little bit easier for you. Okay, so number 4. Number 4, you have, let's say, 3 divided by x plus 2, subtract 2x divided by x squared minus 4. So 3 divided by x plus 2 subtract 2x divided by x squared minus 4. So again, first step, since these are not monomials, is to see if you can factor the denominators. So I cannot factor x plus 2, but I can factor x squared minus 4. So when I factor x squared minus 4, I'm going to get x minus 2 times x plus 2, because that's the difference of 2 squares. So I'm going to go ahead and rewrite this as 3 divided by x plus 2 subtract 2x divided by x minus 2 times x plus 2. All right. Now, let's find the LCD. So remember, the LCD has to include every factor you see. The question is, how many factors will you need? So here, there's a factor of x plus 2, one factor. Here, I see another factor of x plus 2, and there's only one. So one factor here, one factor here. Now remember, when I say there's only one factor, you're looking at the exponent. That's a 1. If you put this in parentheses, that's a 1. So I need one factor of x plus 2. All right, the next factor you see is an x minus 2. I don't have any here, so there's none here. There's 1 here, so I need 1. And then I already took care of the x plus 2. That's this one right here. All right, so there's your LCD. So now you're going to write equivalent fractions. So equivalent fractions. So you're going to write two fractions with that denominator, just like this. So two fractions. You want to write an equivalent fraction to this one with this denominator, though, instead of x plus 2. And over here, you want the same thing. X plus 2 times x minus 2. All right. Now, okay, so let's write equivalent fractions. See, you have a factor of x plus 2. So if you look at your LCD, I already have this x plus 2. The question is what's missing. So this is what's missing. So whatever is missing is what you got to multiply this by. So I got to multiply x plus 2 by x minus 2, just like this. But what I do to the denominator, I have to do to the numerator. All right, so you got to say 3 times x minus 2. And it's a good idea to put the x minus 2 behind a 3. All right, so now when you rewrite this here, they'll go ahead and distribute. You need to distribute this. Don't leave it as 3 times x minus 2. So when I distribute, if you recall, when you distribute, you get 3x minus 6. So 3x minus 6 is this. So again, you must distribute this. So don't forget to do that. Leave the denominators in factored form. Leave the denominators in factored form, but go ahead and change the numerators. If the first numerator that's in factored form, go ahead and distribute. So write as a polynomial that's not in factored form. And then over here, you see how you have an x minus 2 times x plus 2, and you already have it here. That is your LCD. So since the denominators are the same, the numerators have to be the same. So basically you're saying this. This times 1 is this. So if I multiply this by 1, then 2x times 1 has to be the 2x here. All right. So now what you do, just like you did in the previous lesson, was now you write this as one fraction since the denominators are the same. Again, leave the denominators in factored form. Do not FOIL this out. Leave it alone. And there's a reason for this, because at some point it could be that when you rewrite this, you can still factor and reduce. Okay? So I get 3x minus 6, subtract 2x. Subtract 2x. And now combine like terms, 3x subtract 2x, see this 3x subtract 2x is x. So I get x minus 6 divided by x plus 2 times x minus 2. And this polynomial that's in the numerator, you can't factor it any further. So remember the idea of simplifying. Simplify if possible. So I can't factor any further, so this is your answer. That was number 4. All right, number 5. Let's go to number 5. All right, number 5, you have, let's see. Okay, you have 3 divided by 4x plus 8 divided by x minus 2. So 3 divided by 4x plus 8 divided by x minus 2. All right, so notice in this case I have a monomial and a binomial. And if this was let's say an 8, you could reduce if you wanted to, but I can't reduce anything in this fraction. But this is a monomial, so I can't really factor this. Now here, x minus 2, again, you want to see if you can factor. I can't factor x minus 2, so I'm good with this. So now all we do is find the LCD. So remember, your LCD has to include every factor you see. So the first factor I see is a 4. I have a factor of 4 here. I don't have any other coefficients here, so my LCD is going to include this 4. My next factor I see is an x. I have one factor of x here because of that exponent right here, x in the first. I don't have any other factors of x here. See, this factor right here is x minus 2. It's not an x, it's an x minus 2. So I need an x. My next factor is an x minus 2. I have one factor here. I don't have any here, so I need 1. So this is your LCD. So your LCD is 4x times x minus 2. Okay, so now the next step, remember, once you find the LCD, the next step is to write equivalent fractions. So I'm going to have 4x times x minus 2 plus, and then this fraction, 4x times x minus 2. So you write two fractions with that denominator. So 3x is equivalent to what fraction with this denominator? 8 divided by x minus 2 is equivalent to what fraction with this denominator? All right, so let's just think about what you're missing. See, I have a 4x, so I already have my 4x here, so what's missing is the x minus 2. So I'm going to multiply 4x by x minus 2. But what I do to the denominator, I have to do to the numerator. So I got to multiply this 3 by x minus 2. And it's a good idea to put the monomial in front of this binomial, because at some point you will distribute. You are going to have to distribute. Okay? Over here, let's think about what's missing. You see, I already have an x minus 2 right here. So what's missing is this 4x. So if you need to cover it up. So I got to multiply. So to go from here to here, I got to multiply x minus 2 by 4x. Right here, this 4x. So see, this is now this. But what I do to the denominator, I have to do to the numerator. All right, now be a little bit careful. So some students will make a mistake and say 8 times 4 and 8 times x. Be careful. That's not the distributive property here. The distributive property is where you multiply a monomial, in this case, a monomial into a polynomial. See that subtraction? Here, that's just a monomial right here. So 8 times 4x is just 32x. Okay? All right, so what we get now is when I distribute here, I get 3x minus 6. That's this. Plus, and then 8 times 4x is 32x. All right, now the next step, once you write two fractions with that same denominator, the next step is to add the two fractions, write it as 1. So my LCD is 4x times x minus 2. Again, leave the denominator in factored form. Don't distribute this. Don't say 4x squared minus 8x. Leave it alone, because it could be that when you add those two numerators, this numerator that you end up with can be factored and you can reduce. Okay? So I get 3x minus 6 plus 32x, which equals, and then combine like terms, 3x plus 32x is 35x minus 6 divided by 4x times x minus 2. And so that's your answer. You cannot factor this, so you're good. This is it. All right, so that's going to be part 1, and then part 2, I'm going to have some more problems like these.